Hello everyone, and thank you for watching my presentation. My name is Konstantina Bitsi, and I'm a PhD student at KTH Royal Institute of Technology. Today, I will present you the research work that I have done so far and still intend to do as part of my PhD project. The title of my project is Investigation of Compact Electrical Machine Topologies for Automotive Applications. As we all know, the market of electric vehicles is constantly expanding, as their development and integration in the society is considered a more promising way to ensure a sustainable energy future. Therefore, the design of suitable electrical traction motors is of great importance, with criteria such as cost, torque, efficiency, and space or weight limitations playing a determining role. My PhD project is focusing on the design and study of suitable electrical machine topologies for automotive applications. The objectives of my research include the in-depth electromagnetic and thermal analysis of possible candidate topologies, as well as the optimization of the examined models based on the required specifications. Also, it includes the comparison based on key objectives in order to identify the most suitable and the most scientifically interesting candidates. Finally, the last step is experimental validation of the research work. The electrical machine topologies that have been studied so far include the conventional solutions that you can find in today's propulsion electric drive systems, the interior permanent magnet synchronous machine, as well as the induction machine. An innovative induction machine topology that was introduced by the Bundeswehr University Munich, so-called intelligent stator cage drive or ESCAT machine, combines an asynchronous rotor with a multi-phase stator cage winding composed of solid aluminum bars in every stator slot. Thus, its stator slot corresponds to a potentially separate phase winding and can be individually supplied. Consequently, the structure of the stator winding in this machine design facilitates the possibility of changing the number of pole pairs as well as the number of active phases during operation. In order to decrease the high current levels rising in this topology, the solid bars in each stator slot can be replaced with multi-turn coils that are wound axially along the stator core. In this way, a machine design that is compatible with the present-day high-voltage battery system can be produced, while the useful capabilities of pole changing and phase changing of the ESCAT topology can still be harnessed. This induction machine with wound independently controlled stator coils, abbreviated as WISC, is investigated within the frameworks of my project and was introduced in the paper entitled An Induction Machine with Wound Independently Controlled Stator Coils, presented in the ISEMS 2019 conference. At the moment, we're at the phase of experimentally validating the WISC concept. For this prototype, a standard industrial ABB induction machine was selected and was properly reconfigured in order to convert the stator coils into independent solenoids. Soon, the first experimental results from this prototype will be demonstrated. A big part of my research work also includes the optimization of the studied traction motor topologies for the selected applications. Within the framework of my PhD project, an evolutionary many objective algorithm was developed based on the non-dominated sorting genetic algorithm 3. This algorithm was introduced in the paper entitled Many Objective Optimization of IPM and Induction Motors for Automotive Application, presented in the EPE 2019 conference. This paper presented the design process of an IPM synchronous motor and induction motor for a well-known case study, the one of a Toyota Prius 2010. Both topologies have been optimized considering three conflicting objectives: torque capability, efficiency, and torque density. It was shown that the obtained Pareto optimal solutions of both topologies satisfy the required criteria, rendering the proposed many objective approach an effective optimization tool that offers feasible compromise among various targets. Additional publications related to my research project were presented during the conference ISEM 2020. These papers are focused on the topics of preliminary electromagnetic sizing of axial flux induction machines, a transient model of the WISC machine that I presented to you based on permanent networks, and finally, work on iron loss computation using MATLAB and COMSOL multiphysics. And with this, a brief presentation of my work is concluded. Thank you very much for your time.